Okay, so today we're going to focus on the transformation of functions. So we are going to apply transformations to the graphs of functions. Okay, and we are also going to apply dilations. Do you guys remember that from geometry? Dilations, transformations. Transformations are just like you're going to slide it, right? Dilations is where something was getting larger or smaller, is what you studied in geometry. So here, we're going to focus on what is called a stretch or a compression. These happen vertically and horizontally. Okay, we're going to be going over a lot of different rules today, and then we're going to practice applying them. And then we're going to have compositions of transformations, which means we're going to combine several of the transformations we're going to talk about, and we're going to use that to write equations. Okay, so the first thing we're going to talk about are translations. We mentioned the parent function yesterday. When you have a family of graphs, that includes graphs that have at least one characteristic in common, and the parent graph is transformed to create other members in the family. Okay, so we start with the parent graph, which is the simplest function. Right, and we take that simplest function and we apply different transformations to it. Okay, so the constant function is the first one we're going to talk about. They're going to use function notation. So f of x is equal to a, where a is any number. You may have also seen this as y is equal to c, okay, where c is a constant term. A constant term is just a number. So we were working with constants yesterday. We had y equals 4. The output was always 4. Okay, and then this one, they say it's the identity function. We're just going to call it the linear function. Okay, so if it's a linear function, f of x equals x, this is called function notation. We are going to start using that. But remember, function notation is just another way to write that output. So whenever you have a linear function, y equals x, it's another way that you can write that. Okay, and then they also talk about the domain. So if it's a constant, your domain is all real numbers. Your output is just that constant. The domain and range for a linear function is going to be all real numbers. Yesterday, we also talked about the absolute value function. So f of x equals the absolute value of x, which again is the same thing if you use y equals. And then we have the quadratic function, which is y equals x squared. Okay, so again, look at your domain. Your domain is going to be all real numbers. That just means you can plug in any number and you can get an output. Okay, the range they're telling you for this is going to be all the points are above 0. Same thing here. All the points are going to be above 0. Right? We actually aren't going to worry too much about your domain and range today, but they are giving you that for those parent functions there. We're going to talk about translations. So translations happen when you just slide a figure from one position to another and you don't turn it. Okay, so you can slide it up or down, left or right, and we have a few rules that are going to go with that. Okay, and we're going to write them in the translation rules over here. So we're going to start to use like some formulas. If you looked at math textbooks, you can see that sometimes they have all these formulas in different boxes, and sometimes they can be a little confusing. So we're going to make sure we understand what those mean. So if you are moving a function up or down, the rule is you have a function f of x plus k, and if the value of k is positive, that means it's going to go up, and if the value of k is less than 0 or negative, that means it's going to go down. Okay, so a lot of times these boxes are going to use symbols to indicate what's happening. Okay, the other one that's a little bit trickier is when you are moving left or right. So if you are moving to the left or right, you have to pay attention to your parentheses. Okay, this is what we call the rule. So your rule is f of x minus h. We're going to pay special attention to this sign. So we know that it's a negative, but it also means the opposite. Okay, so if your value for h is positive, okay, that means the graph moves right. Okay, so if you had f of x minus h, that's what it's going to look like. I'm going to show you in a second what this looks like with actual numbers because I think that's useful. And then if your h value is a negative, the graph moves left. So if you plug in a negative, right, you have f of x minus negative h. Okay, you're going to have f of x plus h here, because minus a negative is going to simplify. Okay, so an example would be if h was negative 5, if you were to plug that in, you would have f of x minus negative 5, which would be f of x plus 5. So if it's a negative, it's moving to the left, but what you're going to see in the equation is this plus, okay? And then if your h value is positive, let's say it's 2, if you plug that in, you'd have f of x minus 2. That's what you would see in the equation, okay? Because you're plugging it in to this. This is the rule. Okay, but h is positive, so that means it's going to the right. We also have to know some standard forms for quadratic and absolute value. Really, the quadratic, we're going to use what other books like to call vertex form, because you can see the vertex right away. You can pick it out, and so that's helpful. So for a quadratic, it's f of x equals x minus h squared plus k. Okay, so this is called a vertex form. You're probably not super familiar with that. Generally, when you're doing quadratics, you probably talked about them in this form, ax squared plus bx plus c. Okay, we're not going to be working with that today. We're only going to be working with this vertex form. Okay, and it's called vertex form because you can see the vertex right away. It's h and k, which were two values we were just talking about. Remember, the h value is going to tell you what happens left or right, and the k value tells you what's happening up or down, okay, which is vertical. So the h value is going to be tied to horizontal values. The k value is going to be tied to vertical values. And then we also have the absolute value that can be written in this vertex form. Okay, because just like we saw yesterday, right, when we were graphing these, okay, we had a vertex. Your vertex here was 0, 0. This also has a vertex, 0, 0. Okay, so both absolute value and quadratics have a vertex. So for the absolute value, it's very similar to the quadratic. Okay, it's f of x equals the absolute value of x minus h inside the absolute value, and then on the outside of the absolute value is plus k. So notice the h value is inside the absolute value. It's inside the parentheses here. The k value is on the outside. Okay, so that's going to help us as we start to look at some of our equations and figure out what's happening with these transformations. Okay, I know that was a lot of rules. Now we're going to apply these rules so that we can describe each translation as it relates to the graph of the parent function. When you're describing the translations, if you're relating it to the parent function, you need to include the parent function equation. Okay, so you have to include that in your explanation here. Right, so if we look at A, y equals x plus 5, what type of function is that? That's linear, okay, because the exponent is 1. What's that? Oh, EQN, so I just abbreviated equation. So make sure you include your equation in your explanation. If it's a linear, because you don't have any parentheses, you're only going to have to tell me if it's moving up or down with the translation. And you can use either f of x or y. This is a y, so I'm going to use y equals x. So what we would say is y equals x is translated 5 units, and then is it going up or down? Up. Yep, so plus 5 means we're going to be going up. Okay, if you feel like you can do the next two without me, please give that a try. Okay, we're going to start with the parent function. So if you guys want to start that for this one. Okay, so it's not linear because if it's linear, the exponent is 1. What's our exponent here? 2. So that's what type of function? Quadratic. So it looks like some of you don't want to start without me, so I'm not sure if you're nervous about whether you're right or not, or not sure what to do. Okay, so just like we did last time, we're just identifying it's quadratic. So, all right, we're going to start with the parent function of the quadratic, y equals x squared. And then it's translated, we know it's going to be 9 units somewhere, so we just have to figure out where. If you have this plus 9 here, see how it's inside the parentheses? If it's inside the parentheses, is that the value of h or k? H. Okay, so let's pick out what our h value is. Remember how it's x minus h? So if you see the plus value, your h value is what? It's a negative. So h is negative 9. So that means we're going 9 units where? We're going 9 units left. Okay, so if you have that, you see the plus 9, it comes from minus a negative. Okay, so you have a negative, which means you're going to the left. Okay, can we confidently try the last one? Yep, that's the value. This one does have two things that you're going to have to include in there. But again, you have to start with your equation. So make sure your explanations look just like mine. Okay, so we're going to have y equals the absolute value of x. That is translated 4 units in what direction? Right. Okay, because your h value is a positive 4. Your k value is a negative 2. Okay, so that means you're going 2 units down. So y equals the absolute value of x is translated 4 units right and 2 units down. All right, for our next set, we're going to use the graph of each translated parent function to write its equation. So we're going to write an equation for each. Anytime you're writing an equation, just make sure that you're including either a y equals or an f of x equals. Okay, don't just write an expression if it's asking for an equation. Okay, and you can decide which one of those you want to do. So I like to identify what the parent function is. If it's a parabola, we know that the parent is what? If it's a parabola, quadratic. Yeah, y equals x squared. Okay, so the simplest way to do this is going to be to find the vertex. So here's your vertex, 0, 5. Okay, if we look back at what we wrote down about the standard equation, okay, we know the vertex is going to be h and k, so we can plug that into this equation here. Okay, so I'm just going to write down that vertex form so you can see it before you plug it in. Okay, and we know that the first one is h, the second one is k. We're just going to substitute. So this is x minus 0 squared plus 5. And then you do need to simplify this. So x minus 0 is just x. So this is x squared plus 5 is equal to y. Okay, and that would be your equation. Okay, and you don't even necessarily have to show all this work. I just want you to know that whatever your vertex is, that's what you're plugging in. Okay, the parent function, the vertex is at 0, 0. So if you plugged in 0, 0 and you simplified, you would get your parent equation there. All right, and then for B, again, we're looking at the shape. So based on the shape, this is what type of graph? Yeah, good. And then again, we're just going to take the vertex here, and we're going to plug it in to f of x equals x minus h plus k. Okay, so let's see if you can do that and simplify it all the way down, okay? And if you've already done it, you can go ahead and start thinking about dilation. Okay, so you have -3, -4. Okay, so your vertex is -3, -4. Okay, and then when you plug this in, x minus a negative 3 is going to transform to x plus 3. I decided to use f of x for this, just so you had an example of each. Again, it doesn't matter to me whether you have f of x or y equals, just as long as you have an equation. So make sure that you have the plus here. So minus the negative is going to turn into the positive, okay? All right, let's talk dilations and reflections. Okay, so when you're dilating something, you are either going to stretch or compress. It is going to make that graph either narrower or wider. And we are going to look at these in terms of a vertical stretch or a horizontal stretch. Okay, so if you multiply a function by the constant with respect to the y-axis, okay, then you have a rule that looks like this, a times f of x. Okay, so if you multiply a function by a constant, that's going to dilate the graph with respect to the y-axis. This is going to be one of our rules. Okay, you can also multiply the independent variable by a constant. And when you do that, it's going to affect the x-axis. And that rule looks like this, f of a times x. Okay, where a is a constant term. So we're using a as a constant there. Okay, so based on what that value is, you're either going to have a stretch or compression. The first ones we're going to talk about are vertical stretches and compressions. Okay, so the rule is a times f of x. We use f of x so we can apply it to different functions, okay? And if that value of a is greater than 1, when you take the absolute value of it, then that is going to be what we call a vertical stretch. And if that absolute value is between 0 and 1, then we call that a vertical compression. Okay, and we're taking the absolute value because we want to see what's happening when you're using that positive value. The negative is actually going to represent something else that we're going to talk about. Okay, and then if there's a horizontal stretch or compression, the rule is you are multiplying that constant times x, and you're going to see that inside the parentheses. So I always think of this as it's inside the parentheses, this factor is outside the parentheses, and then these rules flip-flop here, okay? If your value of a, the absolute value of a, is greater than 1, this is a horizontal compression. Okay, Okay, so if it's greater than 1, it's a horizontal compression here. And if the value is in between 0 and 1, this is a horizontal stretch. Okay, and I'm okay if you abbreviate that, the HORC. Just remember when you have a stretch, you're thinking of something being pulled. Yes, stretched, that should make a parallel. Stretched means you're pulling it, and then compress is like a push. Okay, so if you are stretching something vertically, you are pulling it apart. Okay, so you can stretch it vertically, means from the top and the bottom. When you stretch something horizontally, okay, it's going to be left to right. I wish I had something cool to show you that. You know what's squishy? Pretty cool. Okay, and then for horizontal, if it's a compression, horizontally is left to right, so you would push it. Okay, and then a stretch, you would pull it. So for the vertical one, you're either stretching it this way or you're compressing it this way. Okay, and then I'm gonna show you a few things on decimals with that as well. Ooh. And then we also need to know about reflections. Okay, so that's when you have a flip over a line of reflection. This says in a line of reflection. You can say in or over. I like over better. And then often when we do this, it's going to be over the y-axis or the x-axis. Okay, so they tell you up here, if you have a negative f of x, it's a reflection in the x-axis. And if you have f of negative x, that is a reflection in the y-axis. Okay, so we're going to have to remember these rules. So if the negative is on the outside, it's a reflection over x. If it's inside, it's going to be over the y. So you guys are going to have to remember those. I try to come up with ways for me to remember so I don't have to keep looking back and forth. So for me, like my parents write me a birthday card, they always sign it XOXO Bumpy. So what I remember is if it's XO, the XO tells me that that means X is on the outside. That helps me remember it. And then for the Y's, Y and I, they rhyme, right? So if it's Y, it's going to be inside. Okay, so if you want to use my little tricks, you can. If you want to come up with some of your own, you can. If you're just going to remember those, that's fine. Because I know sometimes we get in a test situation and then we second guess ourselves, right? Like, oh, is it outside or is it inside? Okay, so for examples 3 and 4, it says describe each dilation and reflection. So you're going to have both of those in there. Again, it says as it relates to the parent function. So your parent functions that we're going to focus on for this unit are y equals x squared, and y equals the absolute value of x. So you need to have that somewhere in your explanation. Okay, I'm going to do some annotations here. I'm going to talk to the text math style, which is where we try to figure out what these values mean. So when you're looking at this, hopefully we can see that this is the absolute value, right? This is y equals the absolute value of x. That's what's being transformed. And then we have to determine what type of reflection it is. So your negative is on the outside. If it's on the outside, that means it's reflected over what? Over the x. And you can say over or in. In sounds awkward to me. In the line of reflection. So y equals the absolute value of x is reflected over the x-axis and is, and then we also need to look and see where this is. Okay, so the rule is either that the value is applied to the independent variable or to the entire function. So this is outside, this is inside. Okay, so this here is a constant that's outside. And what's the absolute value of negative 2? 2. So if 2 is greater than 1, it's going to be vertically stretched or compressed. Stretched. Okay, so you don't have to write all that down when you're doing your homework, but that's what you should be thinking about in order to get your answer. Okay, it's a constant that's on the outside. The constant is greater than 1. That's what makes it a stretch. Okay, so I want you guys to try B, C, and D. You can do it. It might not be super easy for you, but we can look some things up. We can do hard things. We have the tools. The inside that has a square, so we should start with saying y equals x squared is reflected over the y-axis because it's inside, and it is, and because this is inside, it has to be something happening horizontally. Again, you have the absolute value, which is 2 is greater than 1. So if it's horizontal, is that a stretch or a compression? Yep, so we can say it is compressed horizontally. You can say it's horizontally compressed. Either one of those is fine. Okay, if there are no parentheses, it's just going to be happening on the outside, and you won't have parentheses with a linear function. Okay, so y equals x is reflected over the x-axis. Okay, so it's on the outside. And then the absolute value of 1/4 is, the absolute value of negative 1/4 is 1/4, which is between 0 and 1. Okay, so it is compressed vertically. Or you can say it's vertically compressed. Okay, and then for this one, it's inside. It's the absolute value. So y equals the absolute value of x is reflected over the y-axis. Okay, it's inside. That's how we know it's over the y-axis. And is, our constant is inside. So we can say it is horizontally stretched. And again, it is stretched because 2/3 is between 0 and 1. Okay, so now we're going to describe each transformation as it relates to the graph of the parent function, which is almost the same as what we did here. It's just these were only dilations and reflections. Okay, these are going to be all of those combined. Okay, so I want you to work with your row and see if you can come up with the answers to those three. The x-axis, good. Okay, it is vertically stretched. And again, it's a vertical because this is on the outside. It's stretched because it's greater than 1. And it's translated 1 unit where? Yeah, what is it? Which one is it? So if it's inside, it's right or left. And if you see the minus, remember your H value is a positive. Okay, so it's 1 unit to the right. Okay, and again, it's because your H value is positive. Okay, if it's a K value, that's when it's up or down. So the K is always going to be like on the outside of a value, or if you don't have parentheses, it's going to be a K value. All right, and then here, you have this inside and you have this outside. So y equals x squared is, now 5 over 2 is a fraction, but 5 over 2 is what number? 2.5. So how does that compare to 1? Yep. So this is going to be horizontally compressed. Okay, so horizontally compressed. Because remember, vertical and horizontal, they switch rules. And it's translated 2 units where? Yep. Translated 2 units